Okay, 4.8, problem solving with trigonometry. We're going to continue using the sign feature of our calculator to solve some problems. So, this first problem says, find the area of the triangle to the nearest 10. What is the formula for finding the area of a triangle that you guys learned back in elementary school or middle school? What's the formula for finding the area of a triangle?
It was base times height divided by 2.
Perfect. Base times height divided by 2, or
base times height on base times height times 1/2.
Right. Same thing. Base times height divided by 2, or 1/2 base times height. However, if you look at this triangle, I see a side is 12 millimeters, another side is 15 millimeters, and they gave me an angle measurement. The 12 and the 15, those are not necessarily the base and the height. I can use any of these as the base, but the height has to be perpendicular to the base. It has to form a 90-degree angle with the base. Is the side that is 12 millimeters, is it forming a 90-degree angle with the side that is 15 millimeters?
No.
No, it's not. So I cannot say that the 12 millimeters is the height. Okay? However, what I can do is I can draw a line from the vertex, from a vertex to the other side, and that would be the height, because it's from one point, from one vertex to an opposite base, an opposite side, and it would be perpendicular. So what I've created now is the height. And also, if I continue drawing this out in blue, what did I create? A right triangle. So, if I wanted to find this piece with the right triangle, I could, because I have an angle measurement, I have a right triangle, this is the hypotenuse of my right triangle, and I'm looking for the opposite side of my right triangle. So what function would I use, sine, cosine, or tangent, if I had the opposite side and the hypotenuse? Look at your notes. If I have O and H, O and H, it would be sine. Now, I can't use the side that says 15 millimeters because I know the whole thing is 15, and I drew my line from the vertex to the other side. I don't know where it's intersecting the base, so I couldn't use the adjacent side. I would have to use the hypotenuse, because that's 12, and then I'm looking for the opposite side. So, if I wanted to find the height of the triangle, I would use sine to do that. So it would be sine of 34 degrees equals opposite x over hypotenuse, which is 12. I'm doing this right now just to find the height of that triangle that we marked with x. Okay, so sine of 34 degrees equals x divided by 12, opposite divided by hypotenuse. The goal is to get x by itself, so what am I going to do?
Times 12.
Multiply both sides by 12. Multiply both sides by 12. So now I have 12 times the sine of 34 degrees equals x. So in your calculator, I would suggest you do 34 sine first. So 34, hit the sine button. Then you're going to multiply it by 12. And let's go to 4 decimal places. How tall is it to 4 decimal places?
Wait, 4 now?
Let's go to 4, because, well, we're not done with the problem yet, so I want to go to 4 places.
7103.
7103. Carly, if you guys need to move the desks more this way, you can. Okay? 6.7103. So what we just found now is the height of the triangle. So now I can go back to my original equation, which is base times height divided by 2. So I have my base. Now I'm going back to my original triangle. I'm going to outline it in red. Okay? The base of my original triangle is 15. The height of the triangle is what I just found, which is 6.7103. 6.7103. And I'm going to divide that by 2. So if you still have that in your calculator face showing 6.7103 blah, 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 you can just do times 15, press equals, and then divide that by 2.
50.30.
Go to the nearest tenth. What would it be to the nearest tenth? 50.3 millimeters squared. 50.3 millimeters squared. Now that was like really 2 steps. We had to use sine to find the height, and then we had to take the height and plug it into base times height divided by 2. Okay? I'm going to show you now a shortcut that you do not have to do all of that work. If you want to do all of that work, you can. We create a right triangle, we find the opposite side, we use the opposite side as the height, and so on. But there's a formula that we can use instead of having to do that work. Okay? Nope, not perimeter. Perimeter and height are not the same. So let's look on down to area formula for a triangle using trigonometry. So this triangle on your paper has angles A, B, C. Okay? And so we have side BC, side CA, side AC, and they also are calling the sides just as side A, side B, side C. Okay, lowercase ABC. So the area of a triangle ABC with sides lowercase a, lowercase b, and lowercase c can be found using the length of 2 of its sides and the sine of the included angle. So here's what included means. If I am talking about side BC and sides BA, or side A and side C, side A, side C, what is the included angle? Angle B is the included angle. That's what included angle means. It's the angle that connects the 2 sides. So if I wanted to find the area of this triangle, I could just say, well, it's going to be 1/2 of side times the sine of the angle. So here's an example of doing it back with our original question. I'm going to erase all this so we can see a little bit better. We have a side, and an included angle. So we can find this. So it would, and it's always the sine of the included angle. So it's 1/2 of 12 times 15 times the sine of 34 degrees. Okay? So we're used to, here's the deal. We're used to 1/2 times base times height. Well, you can think about it as pretend this is the base, pretend this is the height. The only thing that you're adding in now is you're adding in the sine of the angle they give you. So on your calculator,
Wait, what is that?
let's put this in first, 34 sine times 15 times 12, and you can either do divided by 2 or times 0.5. 50.3, which is what we got when we did the long way as well. Okay? You like the long way better? The short way, yeah, me too. So let's do a couple of examples. Example 2, find the area of the triangle to the nearest 10th. Well, what I have to make sure is, so I have area equals 1/2. I have a side, 3.2, times the side, 4.7, times the sine of the included angle. What is the included angle? 142 degrees. And that's it. Now you're just plugging everything into your calculator. I would suggest plugging in the 142 sine first, and then keep multiplying from there. So on your own, I want you to plug it into your calculator. Let's see if we all get the same answer. And if you want to double check that you're looking at the numbers on your paper, instead of on my board in case I wrote something down wrong. You can't read my writing.
4 point.
No, don't say it out loud. If you have it, show me on your calculator. I'm walking around.
Good. Do we round to the nearest 10?
Round to the nearest 10th unless it tells you otherwise.
Okay, so 142 sine times 4.7 times 3.2 equals, and then either times 0.5 or divided by 2. You're right, divided by 2 or times by half. You just multiply it by 2. You divide by 2. So divide by 2. That's your answer. Not either divided by 2 or multiplied by 0.5.
Dude, you almost killed me.
Okay, so to the nearest 10th, what was the answer? A equals 4.6 meters squared. Okay, anyone have an issue plugging this into your calculator? We feel good? Okay, let's do another one. Now, this particular one, you're going to want to draw the triangle. So, it has in triangle DEF. So just sketch out a triangle. Doesn't matter what it looks like. You need to label the points. It does not matter where you start labeling it, but you need to make sure that you go in a circle. So I'm going to start this one. This is going to be D. This is going to be E. This is going to be F. Okay? Especially when we start quadrilaterals next week, it's really important that once you start naming it, you name it in a circle. Theo, I'd like you to put your phone away so you're not tempted by it. Thank you, sir. So in DEF, DE is 9 inches. EF is 11 inches. DF is 13 inches. And the measure of angle D is 57 degrees. So your triangle should look like that. And I want you to circle the numbers that we're going to use to solve this problem. Don't say it out loud. Or, you can do cross out the number we will not need. It's a number we're not going to need. To solve this problem, there's a number we will not need. What number did you cross out? No. 11. 11 is the one we will not need because we need this. They only gave us one angle, so we're definitely using this angle. Well, then we have to use the two sides that the angle's between. The angle is between 9 and 13. So we will not need 11. So our formula, area equals 1/2 of 9 times 13 times the sine of 57 degrees. Okay, go ahead and solve it on your own. I want you to write the answer to the nearest tenth. So A equals what? Don't forget your units. Do not say it out loud. Just write it on your paper. Hold on one second. Let me double check that I've got the right answer. Don't forget to divide by 2 or multiply by 0.5 at the very end. Yep, got it to the nearest 10. Round to the nearest 10th. Make sure you have divide by 2. Yep, round to the nearest 10. Good job. Round to the nearest 10. Yep, round to the nearest 10. The 10th is the first decimal spot. Round to the nearest 10, but that's the right number. Yeah. Except this is what she's saying. So this is the nearest 10 right there. She has the number before. Okay, so I see a lot of you, or all of you, got the right answer. It was 49.06 in your calculator, so 6 tells a 0. You become a 1. 49.1 inches squared. Do not forget the units. Your answer is incomplete without the units. I do not. I don't think. You can grab some paper towel and go into the other room if you want. Okay, so backside. When they say that we are going to solve a right triangle, when they say solve the right triangle, that means that we are finding the lengths of all of its sides. How many sides does the triangle have? 3. So of all 3 of its sides. And the measure of all its angles. And again, 3 sides, 3 angles. So to solve a right triangle, we need to know 2 side lengths, or we have to know 2 side lengths and 1 of the acute angles. So solving a right triangle literally means I have a right triangle, I know what all 3 sides are, what all 3 angles are. We're going to be using some SOHCAHTOA, we'll be using some Pythagorean Theorem, and so on. So first of all, it says to solve the right triangle. Well, let's think about its sides first. I have MD and I have JD. So I still need JM. What can I do to find the measure of JM? Not 5 times 2. You remember what that's called?
Oh, yeah.
Pythagorean Theorem. Yes. So, are we looking for one of the side? Are we looking for one of the legs, or are we looking for the hypotenuse? We're looking for the hypotenuse. We're looking for the side across the right angle. So we have 2 squared plus 5 squared equals c squared. What's 2 squared? 4. What's 5 squared? Equals c squared. What's 4 plus 25? 29 equals c squared. Last step, I'm not looking for c squared, I'm looking for c, so what do? Take the square root of it. So the square root of 29 equals c. Can the square root of 29 be simplified at all?
No.
Nope. So our first answer is, I have JM, and it's the square root of 29. So now I know all 3 sides.
Why couldn't we put it in the decimal place?
You could, but decimals end up being rounded, and so technically the square root of 29 is a more precise answer because it's not rounded. It's like saying, I can either give you $3.49, or if I round it, $3.50. Okay? Obviously, they're close, but they're not exactly the same. Okay? Good question, though. That's why when we're solving the problem, like that very first problem we solved, and I had you guys find the height, and I said to go to 4 decimal places, because technically it's a more specific answer. It's a better answer because it hasn't been rounded as much as if we round right then to nearest 10. Okay, so we have all 3 sides now. So now we need to focus on the angles. We have 3 different angles in this triangle. We have angle J, angle M, and angle D. We already know how much one of them is. Which angle do we already know?
Oh, D.
Which angle? An angle is of 1 letter. Do I know angle J, angle M, or angle D?
D.
D. How much is D?
90.
90 degrees. So we don't need to find D. We need to find J and M. So let's find J first. So from the perspective of J, what side is JD? Is that opposite, adjacent, or hypotenuse? Adjacent. From the perspective of J, what side is MD? Opposite. So I can use these numbers to help me find an angle measure. What function uses adjacent over and opposite? Look at your notes. What function uses opposite and adjacent? Tangent does. Now, remember, I'm looking for an angle measurement. So I'm going to be looking I'm looking for an angle measurement, so I'm going to be using inverse tangent. So the inverse tangent of opposite, which is 5, over adjacent, which is 2. So I'm looking for angle J, and really I should have written that, sorry. Angle J equals the inverse tangent of 5 over 2. Since we're looking for an angle, we're using inverse tangent.
What does inverse mean?
Opposite. So when that's
it's
there's actually a button on your calculator. Were you not here when we did less than 4.6? So it's second tangent, okay? So on your calculator, you need to figure out what 5 divided by 2 is first. You have to work inside of the parentheses first. What is 5 divided by 2?
2.5.
2.5. That's what you should be seeing on your calculator is 2.5. If you don't press equals, when you hit inverse tangent, it's just going to be giving you the inverse tangent of 2, which is not what we want. So 5 divided by 2 is 2.5. Now you're going to do inverse tangent. So second tangent, 68. Let's go to the nearest tenth. So 68 point how much?
Wait. How you did that again?
So 5 divided by 2 equals second tangent. That's it. What do you have? Do it on your calculator. It was 68.19, so 68.2 degrees. Theo, just do it on your calculator.
I'm doing it.
Did you do 5 divided by 2?
Yeah.
Equals?
Yeah.
What does it say? Now what do you do? Second tangent. You already said that. Second tangent. Okay. You're the one who even said it out loud what to do. So now we have angle J. It is 68.2 degrees. So we found this angle. Now we need to find angle M. So from the perspective of angle M, what side is 5? Adjacent. And what side is 2? Opposite. Now, guys, if you wanted to, you could use MJ, the hypotenuse, which we found to be the square root of 29, but I don't want to work with square roots if I don't have to. Okay, that's why I'm just working with 2 and 5. They're a lot better to work with. So we're using opposite adjacent again. So we would do angle M equals inverse tangent of 2 divided by 5 this time. The numbers just switch around. Opposite over adjacent. So 2 divided by 5 equals, what does it say on your calculator? 0.4. And then inverse tangent, 21.8. So angle M equals 21.8 degrees. Angle M equals 21.8 degrees. Now, I'm going to give 3 extra credit points to somebody who can tell me what I could have done differently for angle M. After I found angle J, I could have done something else to not have to do this to find angle M. Hold on, you have to raise your hand. Chris? No, good try. Theo? Nope. What's the relationship between these two numbers?
You could have added 90 and 68.2 to get your third angle.
Out. Yeah, you're on the right track. I could have added them and then subtracted it from 180, or I just could have said, I know these two add up to 90, so if I know one, I just subtract that one from 90. Okay? So we didn't have to do this last one right here. I know that M and J have to add up to 90 because D is 90. So on your calculator, take 90, subtract 68.2.
21.8.
Which is what we found, 21.8. So you don't have to do the inverse twice. Once you find one of them, subtract it from 90 and you have found the other one. Make sense? Okay, let's do another. So we have all 3 sides, we have all 3 angles, we're good to go. Okay, so now we're going to do one more problem. This one's got a lot of words. We won't let it confuse us though. So a building has a 33 meter shadow when the sun is at an angle of 27 degrees to the vertical. Solve the triangle. So we're figuring out how tall the building is, how far is it from the top of the building to the tip of the shadow, and what angle does the ray from the sun along the edge of the shadow make with the ground. So we have to find, we already know DE. So we need to know FE. We're looking for FE, which is how tall the building is. We are looking for FD. And we know this angle is 27 degrees. We know this angle is 90. So now we're also looking for angle D. Oh, let me get a different color.
Wait, the angle.
We know angle F is 27 degrees. It pointed that for us.
Oh, so just take 90 minus 27.
So angle D is 90 minus 27. So how much is angle D?
63.
So we already found it. Don't even have to do any inverse stuff. 90 minus 27, we have angle D.
That's good.
Okay.
Is this how they find the weather?
The weather?
Like how they know how many degrees it is outside? Is it how they know?
No. No. Good guess, but no. Okay. So now we need to find FD or FE. I would say let's find FE first, because if we know FE, we can use the Pythagorean Theorem to find FD and not have to use sine, cosine, tangent again. Okay? So from the perspective of 27 degrees, we're going to find FE. So from the perspective of 27 degrees, what side is FE? Good morning, Ruby. What side is FE from the perspective of 27 degrees? It's adjacent. And we have to use this side because that's the number we know. What side is that? Opposite. What function uses opposite and adjacent? Tangent. So the tangent of 27 degrees equals opposite, which is 33, over adjacent, which I'm going to call FE. I'm going to give another variable. Tangent of 27 equals opposite, 33, over adjacent.
Would that be times FE on both sides?
Multiply F, so we'd multiply FE on both sides. And when we do that, what do we then have to do here? FE is not by itself. Now what do we have to do? We have to divide both sides by the tangent of 27. So technically FE and tangent 27 just switch places because we would have divided this by the tangent of 27 degrees. So it would be FE equals 33 over the tangent of 27. Whenever your variable is in the denominator, it just switches places with what's over on the left-hand side. So do 33 divided by 27 tangent and press equals.
64.7. 64.8.
It says go to the nearest meter. Nearest meter, that means the nearest whole number.
65.
65. So FE is 65 meters. No, because we didn't find the area. I just started writing square because you said that. But no, we didn't find the area, just the dimension itself is 65 meters. So FE, 65 meters. Okay, so we can find FD two different ways now. We know that DE is 33. We know that this to the nearest meter is 65. So we can use the Pythagorean Theorem to find FD. Or we can use sine, cosine, or tangent to find FD. What would you guys prefer to try?
Pythagorean Theorem.
Pythagorean theorem? Okay, we'll do Pythagorean theorem. So the Pythagorean theorem is the 2 legs squared. So 33 squared plus 65 squared equals c squared. Okay, so what is 33 squared? 1089. Plus what is 65 squared? 4225 equals c squared. Add the two numbers together.
5,314.
5,314 equals c squared. What's my last step?
Square root.
What is the square root to the nearest meter?
73.
73. So the nearest whole number. I know we had to find 3 things here. I understand. So we just found FD was 73 meters. Okay? So as a recap, we found angle D pretty easily because we did 90 minus 27. Then we found FE by doing tangent. Okay, we found one of the sides by using trigonometry. But then we found the third side by doing the Pythagorean theorem. Okay, so 3 different things we did, but now we know all 3 sides, we know all 3 angles. That's what they mean by solving the right triangle. Okay, any questions on any of these problems? No?